welcome back to Calculus 2 practice problems. Today we're doing partial fractions decomposition. So we learned this in pre-calc, right? We learned these three things, that if you have some function over two factors, you can split them like this, and then you can find the common denominator, and then when you put everything over the common denominator, it would turn to this function, right? So that one we know from college algebra. But then this one we should have learned in pre-calc, that some function px plus q over x minus a to the n power, it's a over x minus a plus b over x minus a squared, and it keeps increasing in power until you get to that nth power. But we really only go to the 2, maybe 3 in calculus 2. Finally, we have this one, and we don't use it too often, but if we have some function px plus q over a factor x minus a and maybe another one, but we also have this factor which has an x squared in it. That's the key. If it has an x squared in the factor, then instead of a b here, it's a bx plus c. So for example, if you have like 1 over x minus 2 and like an x squared plus 2, right, that's going to factor to be some constant a over x minus 2, and then some, not b, but some bx plus c over that x squared plus 2. And like this b and this b are not the same. This b is representing like some constant that we don't know, and this is just whatever's in front of the linear term. Same with the c and c. So how do we apply this to integrals? Well, let's look at this integral, right? Dx over x squared minus 5x plus 6. In the last video we looked at trig sub, and that's how you would solve this integral, because you could complete the square and get it to look like this, right? And I'm warning you, this is a tough trig sub. You'd have to, it almost looks like a secant, because we have a u squared minus an a squared, except we're missing both the square root and the u term outside of the square root. But since it looks like a secant, we're going to make the substitution for a secant. And we didn't really do this in the last video, but we also have to get rid of this 5 halves here with a 5 halves in the x, right? So you find your dx, and then you plug everything in. And then the denominator turns to this, you factor out the 1/4, and that becomes the secant squared minus 1 that's left becomes a tangent. The tangents cancel, the 1/2 and the 1/4 cancel to make a 2 on top. Finally, you just have 2 integral cosecant theta. Secant over tangent becomes cosecant, right? And then we have the integral of cosecant d theta turns to 2 ln cosecant theta minus cotangent theta. I forgot my c. And then you have to make the triangle, and we already know that x minus 5 halves equals 1/2 secant theta, so we can multiply everything by 2 to find secant theta is 2x minus 5 over 1. Secant theta is h over a, so that means 2x minus 5 is the hypotenuse, and 1 is the adjacent side to the angle. We can use Pythagorean's theorem to find this. This is not a 0, it's an O, this opposite side to the angle. O is equal to the square root of the hypotenuse minus the other side. And remember, that function is what we started with here, right? Except it has a square root and whatever else. Finally, we can find, now that we have all 3 sides to the triangle, we can find our cosecant theta and our cotangent theta. Plug those all into our ln. Do a lot of simplifications, so the 2 and the 2 cancel. Then we can bring this 2 to both the square here and to undo the square root, right? And then we can factor the bottom, cancel out a term, just to get this answer, right? So that is a lot of work. There's a much easier way to do that. The way to do that would be to do partial fraction decomposition. We could recognize this immediately as, so ignore the integral sign for now. This will just become, so let's get rid of the dx, since it's really a 1 dx. Really, this is a over x minus 2 plus b over x minus 3. And we could get those on the same denominator, and then that a and b product and sum will just turn to 1. So we have this equation. Let's multiply everything by the common denominator. This is the common denominator between this 1, 2, and 3. term. So we're going to multiply everything by that common denominator, which factors to x minus 2, x plus, or x minus 3. So we're going to multiply that to here, and to here. You should have learned this in pre-calc, but 1 equals a, and then x minus 2 is canceling, you just get an x minus 3, and b, x minus 2. So a and b don't change. So what we can do is we can use test values. When x equals 3, for example, you have 1 equals a times 0 plus b times 3 minus 2, right? So you can solve this equation, because the a times 0 is just 0, to get that 1 equals 1b, which means just that b equals 1, right? B equals 1. Since a and b doesn't change, we can just use different test values of x. When x equals 2, for example, 1 equals a times x minus 2 plus b times 0. And this term obviously drops out. And I forgot to plug in. I used the wrong factor. A times x was 2 minus 3 is a. So then you have a equals negative 1/2, or negative 1. So we know what a is and we know what b is, so you could say that 1 over x squared minus 5x plus 6 is the same exact thing as negative 1 over x plus 2 plus 1 over x minus 3. This should be a minus 2. Right? So if we were to integrate this with respect to x, we could just integrate all of this with respect to x, and these are two easy integrals, right? Because this just becomes negative ln of x minus 2, and this just becomes ln of x minus 3. Those look familiar? Ln of x minus 3 minus ln of x minus 2. Isn't that the same thing as we have here? So which way was easier? Obviously this way, right? So let's look at some more examples. Really the partial fractions part just said to find the indefinite integral using partial fractions decomposition. The partial fractions part was taught in pre-calc, but that was a long time ago. But this really isn't anything new. So for example, this could be represented as a over x plus 3 plus b over x minus 3. And to figure out what it is, let's see, 1 over x plus 3, x minus 3 is equal to some a over x plus 3 and some b over x minus 3. Right, we can multiply all three by the common denominator, x plus 3, x minus 3, to both here, here, and here. That becomes 1 equals a times x minus 3 plus b times x plus 3. Because, for example, the minus 3 and the minus 3 cancel when it goes on top of the b, leaving you with just this x plus 3 and the b here. Now let's use our test values of x. When x equals 3, 1 equals 6b. So b equals 1/6. And when x equals negative 3, 1 equals negative 6a. So a equals negative 1/6. Right? So now 1 over x plus 3, x minus 3 is just a negative 1/6 over x plus 3. So negative plus b, which is 1/6 over x minus 3. So finally, the integral turns into negative 1/6 over x plus 3 plus 1/6 over x minus 3 dx, which is 2 easy natural logs. And that is the final answer. You could condense it if you want, but I would just leave it like that. Okay, so now let's look at a different one. So this one I'm thinking we might have to use this, this third rule over here on. I think we're going to have an x squared as a factor. So let's see, how would we factor x to the fourth minus 2x squared minus 8? Well, ignore the 4 and the 2. Let's call it an x squared minus 2x minus 8. This is probably something we could factor, right? Let's say, for example, say we just called u equal to x squared. Then this bottom equation would turn to u squared minus 2u minus 8. And this is something we could factor. It obviously turns to u plus 4 and u minus 2. Right? No, I have them backwards. It's u minus 4, u plus 2. Right? So really this bottom just factors to, if you plug back in u, you have x squared minus 4 and x squared plus 2 dx, right? So then you have x squared over x minus 2, x plus 2, that's a difference of squares, all times x squared plus 2. So you see this x squared plus 2, we have a, it's no longer going to be a or b or c. This is actually going to turn into the integral of a over x minus 2, that one's easy, plus b over x plus 2, that one's easy. But since this is a squared factored, it's going to be a cx plus d over x squared plus 2. It's no longer just a constant coefficient. Okay, so now we're going to have to figure out what a, b, c, and d are with a lot of test values. So let's see. If we multiply everything by the common denominator, we have x squared equals a times x plus 2, x squared plus 2, plus b times x minus 2, x squared plus 2. Finally, cx plus d times x minus 2 and x plus 2. Right? So we could get rid of two of these, two constants. When x equals negative 2, for example, on the left side we have 4, and this is new too. The other sides were just constants, but in this one we also have to plug the x into there. So when x equals negative 2, let's see, we have 4 equals, this term's going to drop out because of that negative 2, and this term's going to drop out because of what I meant by negative 2 was this factor, right? So the only term that's going to stay is this b term. We have b. When you plug in negative 2, you get negative 4. When you plug negative 2 into there, you get 6. So that means 4 equals negative 24b, and b equals negative 1/6. Okay, so let's do the same thing with positive 2 now. When x equals positive 2, 4 equals, now these two terms are going to drop out because of this factor right here, x minus 2. But the a is going to stay. We have 4 equals a times 4 times 6. So that means 4 equals 24a, and a equals 1/6. Right, so now we have a, we have b. We need to figure out what c and d are. Could we call x equal to 0? What that will allow us to do is get rid of the c term, because the only c constant we have is in front of that x. So when x equals 0, we're going to be able to solve for d. So when x equals 0, we have 0 on the left. We have a times 2 times 2 plus b times negative 2 times 2. and the d dropped out. You have d times negative 2 times 2, right? I mean the c dropped out. Okay, so finally, 0 equals 4a minus 4b minus 4d. And we know what a and b are, so that means we can solve for d. We can also divide everything by 4 and add the d to the other side. That means d equals a minus b. A minus b. Okay. A and b are 1/6 and negative 1/6 though. Well, let's just plug it in. D equals a minus b. A was 1/6. B was negative 1/6. 1/6 minus negative 1/6 is 2/6, or 1/3, right? Okay, so now we have A, B, and D. The way we're going to solve for C, though, is comparing coefficients. This part can get a little bit tricky, but if you were to completely distribute everything and then gather all the terms together, right, you'd have like x squared equals, like, maybe it would look like this: 4a plus 2d plus b times x squared, right? And you can see the coefficient over here is 1, so that means all of this added together must equal 1. So we can do that to find out what C is going to be. What is C going to make? So what I want to do is rewrite all of this over here as, I'm going to rewrite it as x squared minus 4. That way we only have to FOIL once. So this term over here, if you were to FOIL it out, actually, let me bring it down here. Cx plus d times x squared minus 4 turns into cx cubed plus dx squared minus 4cx minus 4d, right? So that means the only terms that are going to have a c coefficient is the x cubed terms and the linear term, right? So on the left side we have 0x cubed plus 1x squared plus 0x plus 0. And on the right side, where are all the x cubes going to come from? Well, here, there's going to be an x cubed, right? Same thing with here. So on the right side, at least, we're going to have a x cubed. If you were to FOIL out this one, you'd just get an ax cubed. And if you were to FOIL out this one, you'd get a bx cubed, right? And a cx cubed. And that's all we're going to need to figure out what C is. Because if you were to do that for the rest, you'd have all of the x squared terms, all of the linear terms, and all of the constant terms. But what we can do is just look at the x cubed terms. These are, if we were to FOIL out all of this, right, the only terms that have x cubed are going to be ax cubed, bx cubed, and cx cubed, right? So we could rewrite that as a plus b plus c x cubed. That must match up to the other side, equaling 0x cubed, right? So ignore the x cubes. A plus b plus c must equal 0. But we already know that a plus b equals 0, right? Because a is 1/6 and b is negative 1/6. So what is c? Well, 1/6 and negative 1/6 cancel, and you're left with c equals 0, right? So we know what a is, we know what b is, we know what c is, and we know what d is. So that was pretty tough to figure out what it is. But this was just algebra. This was just solving a system of equations, right? So if you got a little bit lost through this, maybe it's time to pull out the precalculus notes. The point is, it's really not calculus. We didn't do any, integration or differentiation or tangent lines, the signature calculus stuff. In the next video, we'll start the actual calculus 2 of volumes. But don't get too caught up in finding this, because I'm sure there was a much easier way with all of the different ways of solving systems of equations. This is just a general strategy. Like, you could have used a matrix. You could have you could have done many different things. The point is, we were able to rewrite this integral as this integral, and now we know what a, b, and d are. So a was 1/6 over x minus 2. b was negative 1/6 over x plus 2. And c was 0, so we're just left with d over, and d was 1/3. We're just left with d over x squared plus 2 dx, right? Now the actual calculus starts. Obviously, these first two are pretty easy natural log integrals, but this one is a bit tricky. So let's see. Wait, this is going to become 1/6 ln of the absolute value of x minus 2. This one's going to become negative 1/6 ln of the absolute value of x plus 2. Finally. The last one will become 1/3 the integral of x squared plus 2 over dx. So this is actually an arctan one, right? How are we going to solve this integral? So let's see. If we just call a equal to the square root of 2, then this is just dx over x squared plus a squared. That's just arctan, right? This was from, we looked at this in 2 videos, both the inverse trig integration and the trig sub. But the integral of dx over x squared plus a squared turns into 1 over a arctan of u over a. Right, so in this case, u is just x, and a is square root of 2. a is square root of 2. So we could pull out the 1/6, and we could condense the natural log. Right, and pulling a 1/6 out of a 1/3 just leaves you with a 2. Right, because if you were to put that 1/6 back in, you'd have 2 over 6. And 2 over 6 is just 1/3. And we know that that integral is going to turn into 1 over a arctan of u over a plus c. Right? So, finally, we could just clean this right here up a little bit. So 1/6 natural log of x minus 2 over x plus 2, and 2 over square root of 2 is just square root of 2. Think about it. This is really, 2 is really just the square root of 2 squared. So 2 over the square root of 2, you could cancel the square, so it's just square root of 2, right? Finally, we have arctan of u over a. So just x over square root of 2 plus c. So that is the final answer. So this one was a really tough one. I doubt this would be on any calculus 2 test just because it takes up too much time. Like if you had a proctor, no, this one was pretty tough. So when I say that we're going to look at some harder examples here, it's not going to be the partial fraction that makes them harder. It's going to be the actual integrations. And like once you see trig and exponentials, it might freak you out a bit, but they're really not going to be that bad. If we just call u equal to cosine x, du is equal to negative sine x dx. We almost have it, so let's put the negative in the negative. This becomes the negative integral of du over u squared plus u. So we could complete the square here, and we could do a whole trig sub, or we could just recognize, let's take 1 over u squared plus u, right? That's that could be broken down or decomposed into u and u plus 1, right? Because u times u plus 1 is u squared plus u. And if we multiply everything by that common denominator, on the left side we have 1, with the a, the u terms cancel out and you're left with just u plus 1. And with the b, the u plus 1 drops out. So when u equals negative 1, we have 1 equals negative b. That means b equals negative 1. And when u equals 0, the b term cancels out, right? So you're just left with 1 equals 1a. That just means a equals 1. So we could really rewrite this integral as a negative integral of a over u, or 1 over u, plus b, which was negative 1, over u plus 1 du. So that's going to turn into negative natural log of the absolute value of u, and plus natural log of the absolute value of u plus 1, if you keep track of those negatives. Finally, we could condense this to be u plus 1 over u. Okay. Oh, and also, we should plug back in our function of u. If we started with x's, it wouldn't make sense to leave it as u. So this becomes cosine x plus 1 over cosine x plus c. Right? So that would be the final answer. Finally, we have this one, just in exponential 1. But if we make the sub for e to the x, du is just e to the x dx. Good thing we have that there, because now we can rewrite this as du over u minus 1, u plus 4. So they already did the factoring for us. We know this is going to become some a over u minus 1 and some b over u plus 4. These are more test level questions because you need to know some trig, you need to know some precalc, you need to know the partial fractions, and of course you need to know the calculus too. So let's figure out what a and b are. If 1 over u minus 1 times u plus 4 equals a over u minus 1 plus b over u plus 4. Once we multiply everything by the common denominator, this turns into 1 equals a times u plus 4 plus b times u minus 1. So set when u equals 1, then this term drops out, right? And you have 1 equals 5a. That just means that a equals 1/5. And when u equals negative 4, right, this term drops out, and you're left with 1 equals b times negative 5. That means b is equal to negative 1/5. So this integral turns into a, which is 1/5, over u plus 1. Nope, u minus 1. Plus b, which is a negative 1/5 over u plus 4 du, right? So this is once again two fairly easy integrals. This is just 1/5 ln of u minus 1 minus 1/5 ln of the absolute value of u plus 4. So finally, we can plug back in, well, we can factor out the 1/5 and then condense u minus 1 over u plus 4. And then finally we could plug back in our function of u, which was e to the x. So these are like test level questions because you have to do like U substitution along with some pretty basic partial fractions. So this is what would be more realistic on your test. And that is the final answer. So that is how you do partial fractions decomposition in Calculus 2. So don't stress this problem too much because that one was a really tough one.